Alright, so this is going to be another video about finding the slope at a point, only this time instead of giving you a linear function, this time the function right here, f of x, is going to be quadratic. And it makes the results a little bit differently, and I kind of want you to see the difference between the last video and this one, the last one being linear and this one being quadratic. So here we go. First thing we want to do is it says find the slope of f of x, which is right here, that quadratic we were talking about, at x equals 0 and also at x equals 1. So you're going to be finding two slopes on this one. Okay, the slope of the tangent line, it's going to be the same exact formula where you have the to find the derivative f of x plus h minus f of x over h, and it's the limit of this as h goes to 0. Okay, I already filled in the f of x plus h and the f of x right here for this function. Okay, so I already substituted in the x plus h in here for the x, and then expanded it out here, so you get this whole thing right here, and then also f of x is just the x squared minus 1. So now what I'm going to do with these two things right here is I'm going to substitute them back into the original formula for the derivative, for the slope of the tangent line here, and then we're going to do some algebra and try to figure out how to find the slope at x equals 0 and at x equals 1. So here we go. So the first thing I'm going to do is substitute these in. So this one right here, f of x plus h is equal to this. I'm going to substitute that in over here. So we have the limit as h goes to 0, and then I'm going to substitute this in, so we have x squared plus 2hx plus h squared minus 1, and I'm going to put all that in parentheses because I'm substituting in. It's a very good idea to always put parentheses in there, kind of like we talked about in the last video. Okay, then I'm going to do minus f of x. F of x is right here, so we're going to go minus x squared minus 1. All of this is over h. Okay, now we can cancel some things out here. So we have x squared minus an x squared over here. So I'm going to simplify that by canceling those out. Next, I'm going to do the same thing with this minus 1 minus this other minus 1. So minus 1 minus negative 1 here. Get rid of that. And now you're left with 2hx plus h squared over h. Okay, so now I'm going to kind of rewrite that down here. So we have the limit as h goes to 0. But what I'm going to do here is I notice that there's an h factor in each of these terms here, so I'm going to factor out an h. So we have h times 2x plus h over h. Now the reason I did that is so I can cancel out this h up top and this h on the bottom, so this will cancel out to be 1 over 1. And now what you can do is you could use direct substitution to put this h going to 0 directly in this h right here, so then this would be canceled out too, because then now that's going to be equal to 0 through direct substitution, and you're left with just 2x. Okay, this 2x will tell you the slope of the tangent line at any x that you want. In this case, we want to find the slope of the tangent line at x equals 0 and at x equals 1. So in order to do that, all you have to do is plug in 0 and 1. Okay, so at x equals 0, the slope would be, so the slope of the tangent line at x equals 0 is going to be 0, because it's just going to be 2 times the 0 to be 0. Okay, the slope of the tangent line at x equals 1, you just would plug 1 in here, would be 2. Okay, so that's kind of how you would do this. You'd find the slope of the tangent line as a function. In this case, the function would be 2x, and any x that you put in there, it will tell you the slope at that point. So 0 and 2 because of the 0 and the 1 times the 2 here to get those two values. Okay, to kind of show you this, I'm going to show you on a graph and how this actually works out. All right, so this is a graph of x squared minus 1 right here in the red. Okay, and this blue is going to represent the tangent line, at this case at point 0. So x equals 0, that would be the tangent line. As you can see, based on this graph, the tangent line right here is 0, just like we calculated using the definition of a derivative. If I change this to 1, so if I just move this cursor over a little bit, it shows that the slope at that point is 2. As you can see, it kind of makes sense. It hits the 1 point right here at x equals 1 and forms a line where the slope is 2, just like we calculated using the limit definition of a derivative. So this is meant to just kind of show you how the graphs look and how it actually does show that the slope is determined by the limit process for a derivative. I'm going to link this Desmos file to the video here, so if you want, you can click that. It should be in the info section of the video, so you can actually play around with it. You can actually change this right here to any function that you want, and it'll always find the slope of the tangent line at whatever value of this a right here that you choose. So this graph is just meant to kind of show you that the calculations that we did figure out do make sense and do match the math. So that's finding the slope of a point of a quadratic. Now it's not going to be linear like the last one, so these slopes will be different at different points. Case in point, at 0 it's 0, and at x equals 1 it's 2. So if you have any questions about this, let me know.